Hello, myself Joel Joy, roll number 50. Today I'll be explaining few questions or going through few questions of dbms. First question is, uh, which one of the following is not a part of the asset properties of database transactions? The first option is atomicity, consistency, isolation, and the last one is deadlock freedom. We know that asset properties stands for atomicity, consistency, isolation, and durability. So the wrong answer in this will be option D. Atomicity is basically the entire transaction takes place at all or doesn't happen at all. Consistency is the database must be consistent before and after the transaction. Isolation basically means multiple transactions occur independently without interference. Durability, the changes of a successful transaction occurs even if the system failure occurs. So the correct answer will be option D. Now let's move to question number. The question is not visible here clearly, but it says that in a schema with attribute A, B, C, D, and E, following set of functional dependencies are given. The given functional dependencies are A implies B, A implies C, CD implies E, B implies D, E implies A. Now we need to find out which of the following functional dependencies is not implied by the above set. In order for us to do this question, first we need to understand what is functional dependencies. The explanation of the functional dependencies are, it is a concept that specifies the relationship between two sets of attributes, where one attribute determines the value of another attribute. It is denoted as X implies Y, where the attribute set on the left side of the arrow X is called determinant and Y is called dependent. So the explanation will be basically the closure of sets. CD implies AC, and this plus basically stands for the closure. It gives CDEAB, and in case of BD plus, it gives BD. In the case of BC, that gives CD, and BC plus, that gives BCDEA, and AC, that gives BC. In that, it gives AC plus is equal to ACBDE. And so from here, the correct option will be B. Option B, BD, that gives CD will be the correct option. Now we'll go to question number 1, in which it says that in a relational data model, which one of the following statements is true? The options that are given are: a relation with only attribute is always in BCNF. If all attributes of a relation are prime attributes, then the relation is in BCNF. Every relation has at least one non-prime attribute. BCNF decompositions preserve functional dependencies. Functional dependencies, yeah. So the correct explanation will be, the correct answer will be a relationship with only true attributes is always in BCNF. Let's see why. Because relation with true attributes is always in BCNF, as R of AB gives A implies B is equal to in BCNF. B implies A is also in BCNF. A implies B, B implies A equal to BCNF. No trivial functional dependencies, that gives BCNF. And basically it says that if all the prime attributes, then relation always in 3NF, but may not be in BCNF, because from the second option, it is not, even though it is in a situation like this, it is not always comfort to be in the correct situation. The next is not mandatory of at least one prime attribute in RDBMS. That is basically because it says, it counters option C. It says that every relation has at least one prime non-prime attribute, but which is not the case when it comes to RDBMS. And the last option says that BCNF decompositions preserve functional dependencies. And here it says that not every relation can decompose into BCNF with dependency preserving. Now we'll move to the next question. So in here, the option is A. When we go to the next question, yeah, this is the question that which states that which is the weakest normal form that the new database satisfies, but the old one does not. First normal form, second normal form, third normal form, BCNF. The correct answer will be 2NF because which is the weakest normal form that the new database satisfies. So let's understand each of this one by one. First normal form. In first normal form, what it basically says is that it requires each attribute value in the table to be atomic, meaning it cannot be further divided. Both the old and new database satisfy this requirement because they represent a flat structure where each attribute holds a single value. Now is the second NF or the second normal form in which it states that there are no partial dependencies, meaning each normal prime attribute is fully functionally dependent on the entire primary key. And in the second point, it basically states that in the old database schema, there is a partial dependency present. Volume and number gives year. This means the year attribute is dependent on only part of the primary key. In the new schema, this dependency has been resolved by moving the year attribute to a separate table with its own primary key, thus eliminating the partial dependencies. And now when we come to the BCNF, the Boyce code normal form, the Boyce code normal form requires that every determinant is a candidate key. Both the old and the new databases satisfy BCNF because of all the functional dependencies that are determined by the candidate key. In summary, both the old and the new databases satisfy 1NF, 3NF, and BCNF. The new database, therefore, the second NF is the weakest form. Now, when we move to the next question, that is question number, yeah. The next question that we are going to go through is question number 4, which states that consider a relation R of A, B, C, D, E with following 3 functional dependencies. I think I forgot to explain one part in here, that is the 3NF, the third normal form. The 3NF requires that there are no transitive dependencies, meaning non-prime attributes are not dependent on another prime attributes. Both the old and the new schemas do not exhibit the transitive dependencies, since all the functional dependencies mentioned are between the primary key and the other attributes. And from here, the correct answer will be 2NF. Now, when we go to the third question, it says that consider a relation R of A, B, C, D, E with the following 3 functional dependencies. AB implies C, BC implies D, C implies E. The number of super keys in the relation R is 8. Here the answer is given 8. Let's see how it was actually possible. First is finding the key of the relation. Compute closure of attribute. AB plus gives ABCDE. BC gives BCDE. And C plus gives CE. And from here, only one key is possible for the given relation AB, as it is mentioned in the question. So therefore, the super keys of the relation 2, the formula is 2 into the total number of attributes in the relation. So the total number of attributes is 5 because A, B, C, D, E, which gives 5. So 5 is the total number of attributes in the relation minus the total number of attributes in each key. And from here, we can find out that the total number of attributes in each key is 2, right? So it will be 2 raised to 5 minus 2, which gives 2 raised to 3, which gives to 8 super keys that will be present in the relation. Now, what we will do is we will go to the 20th slide. Yeah, it basically says, consider the following transactions involving 2 bank accounts, X and Y. And they're basically given read of x gives x that implies x minus 50, write of x and read of y that gives y implies y plus 50, and write of y. The constraint that the sum of the accounts x and y should remain constant is that of, they've given four options from here: atomicity, consistency, isolation, durability. Now we'll correct answer from this is consistency. Why? Because as stated in the, as I've said before, in the question number, yeah, consistency is basically the database must be consistent before and after the transaction. The database, meaning that consistency ensures that it is consistent throughout the process. Therefore, when we come to the our question, it basically ensures that a transaction brings the database from one valid state to another, maintaining all the predefined rules, such as the sum of the balances in this case. It basically is saying that it ensures that a transaction brings the database from one valid state to another, maintaining all predefined rules such that all the rules which are implied should not be broken, and such as the sum of the balances in this case. So it should follow that in such a case that the balance should be remaining as it's predicted. Okay. Now coming to the next question, it basically says that assume that in the suppliers relation above, each supplier and each street within a city has a unique name, and that name is given forms a candidate key. No other functional dependencies are implied other than those implied by the primary and the candidate keys. Which one of the following is true from the above schema? So now they have given us options. The schema is in BCNF. The schema is in 3NF, but not in BCNF. The schema is in 2NF, but not in 3NF. The schema is not in 2NF. The correct answer is option A, as it is given here. A relation is in BCNF if for every one of its dependencies x question mark y, at least one of the following candidate holds true. So in this case, S name city forms a candidate key. There is no trivial dependency, and where X is not a super key. Thank you.